The active suspension and adaptive suspension. Semi-active suspension are types of automotive suspensions that controls the vertical movement of the wheels relative to the chassis or vehicle body with an onboard system, rather than in passive suspensions where the movement is being determined entirely by the road surface. See Skyhook theory. Active suspensions can be generally divided into two main classes: pure active suspensions and adaptive semi-active suspensions. While adaptive suspensions only vary shock absorber firmness to match changing road or dynamic conditions, active suspensions uses some type of actuator to literally raise and lower the chassis independently at each wheel. These technologies allow car manufacturers to achieve a greater degree of ride quality and car handling by keeping the tires perpendicular to the road in corners, allowing better traction and control. An onboard computer detects body movement from sensors throughout the vehicle and, using data calculated by opportune control techniques, controls the action of the active and semi-active suspensions. The system virtually eliminates body roll and pitch variation in many driving situations including cornering, accelerating, and braking. Active suspensions, the first to be introduced, use separate actuators which can exert an independent force on the suspension to improve the riding characteristics. The drawbacks of this design are high cost, added complication mass of the apparatus, and the need for rather frequent maintenance on some implementations. Maintenance can be problematic, since only a factory-authorized dealer will have the tools and mechanics with knowledge of the system, and some problems can be difficult to diagnose. Michelin's active wheel incorporates an in-wheel electrical suspension motor that controls torque distribution, traction, turning maneuvers, pitch, roll and suspension damping for that wheel, in addition to an in-wheel electric traction motor. Hydraulic actuated hydraulically actuated suspensions are controlled with the use of hydraulic servo mechanisms. The hydraulic pressure to the servos is supplied by a high-pressure radial piston hydraulic pump. Sensors continually monitor body movement and vehicle ride level, constantly supplying the computer with new data. As the computer receives and processes data, it operates the hydraulic servos, mounted beside each wheel. Almost instantly, the servo-regulated suspension generates counter forces to body lean, dive, and squat during driving maneuvers. In practice, the system has always incorporated the desirable self-leveling suspension and height-adjustable suspension features, with the latter now tied to vehicle speed for improved aerodynamic performance, as the vehicle lowers itself at high speed. Colin Chapman developed the original concept of computer management of hydraulic suspension in the 1980s to improve cornering in racing cars. Lotus fitted and developed a prototype system to a 1985 Excel with electro-hydraulic active suspension, but never offered it for sale. Computer-active technology suspension coordinates the best possible balance between ride quality and handling by analyzing road conditions and making up to 3,000 adjustments every second to the suspension settings via electronically controlled dampers. Electromagnetic recuperative equals. This type of active suspension uses linear electromagnetic motors attached to each wheel. It provides extremely fast response, and allows regeneration of power consumed, by using the motors as generators. This nearly surmounts the issues of slow response times and high power consumption of hydraulic systems. Electronically controlled active suspension system technology was patented by the University of Texas Center for Electromechanics in the 1990s and has been developed by L3 Electronics Systems for use on military vehicles. The ECASS-equipped HMMWV exceeded the performance specifications for all performance evaluations in terms of absorbed power to the vehicle operator, stability and handling. The Bose Corporation has a proof-of-concept model. The founder of Bose, Amar Bose, had been working on exotic suspensions for many years while he was an MIT professor. Adaptive semi-active systems can only change the viscous damping coefficient of the shock absorber, and do not add energy to the suspension system. Though limited in their intervention, semi-active suspensions are less expensive to design and consume far less energy. In recent times, research in semi-active suspensions has continued to advance with respect to their capabilities, narrowing the gap between semi-active and fully active suspension systems. Solenoid valve actuated equals. This type is the most economic and basic type of semi-active suspensions. They consist of a solenoid valve which alters the flow of the hydraulic medium inside the shock absorber, therefore changing the damping characteristics of the suspension setup. The solenoids are wired to the controlling computer, which sends them commands depending on the control algorithm. This type of system used in Cadillac's computer command ride suspension system. Magnetorheological damper equals. Another fairly recent method incorporates magnetorheological dampers with the brand name MAN Ride. It was initially developed by Delphi Corporation for GM and was standard, as many other new technologies, for Cadillac Seville Streets, and on some other GM models from 2003. This was an upgrade for semi-active systems used in upscale GM vehicles for decades. It allows, together with faster modern computers, changing the stiffness of all-wheel suspensions independently. These dampers are finding increased usage in the US and already leases to some foreign brands, mostly in more expensive vehicles. In this system, being in development for 25 years, the damper fluid contains metallic particles. Through the onboard computer, the damper's compliance characteristics are controlled by an electromagnet. Essentially, increasing the current flow into the damper raises the compression rebound rates, while a decrease softens the effect of the dampers. Information from wheel sensors, steering, acceleration sensors and some others is used to calculate the optimized stiffness. The fast reaction of the system allows, for instance, makes after passing by a single wheel over a bump in the road. Some production vehicles with active and semi-active suspension, 1955, Citroën NDS, premiere of fully active self-leveling Citroën hydro-pneumatic suspension, 1957, Cadillac Eldorado Brougham, premiere of active self-leveling GM air suspension, 1983, Toyota Sora, premiere of semi-active Toyota electronic modulated suspension, 1986, Toyota Sora, world first electronically controlled full-air suspension installed, 1987 Mitsubishi Galant Dynamic ECS, world a Euro 1 registered trademark S first production semi-active electronically controlled suspension system, 1987 Lincoln Continental Adaptive Air Ride semi-active suspension, 1989 Citroën NXM. 1987 BMW M3 BOGE adjustable damping system, 1989 September, Toyota Celica fully active suspension, Toyota active control suspension, eliminating anti-roll bars. 1991 introduced on Toyota Sora, 1989 October, Toyota Celsior, 1990 semi-active suspension scanning the road ahead. 1990 Nissan Leopard, Nissan Cedric, Nissan Maxima, Nissan J30 Duet SS supersonic suspension, 1990 Infiniti Q45 full active suspension system, although it did still have conventional coil springs, 1990 Toyota Supra, 1991 Mercedes-Benz first generation ADSI adaptive damping system on S-Class, 1991 Mitsubishi GTO electronically controlled suspension, 1991 Subaru Liberty Air Suspension, 1991 Toyota Sora Z30 Series, 1991 May Toyota Sora UZ-Z32, 1992 Toyota Celica, 1992 Citroën Xantia VSX, 1993 Cadillac, several models with RSS road sensing suspension. RSS was available in both standard and CVRSS systems. It monitored damping rates of the shock absorbers every 15 milliseconds, selecting between two settings. 1994 October, Toyota Celsior introduced first Skyhook air suspension, 1994 Citroën Xantia Activa, 1996 Jaguar XK8 Cats, 1997 Jaguar XJ Cats, 1997 to 1998 Ford Taurus, 1998, world first suspension system combining active heights control and Skyhook TEMS Toyota electronic modulated suspension on the Toyota Land Cruiser 100, 1998, Mercedes-Benz Airmatic air suspension with a DS2 adaptive damping system on W220 S-Class, 1999 September, electronically controlled air suspension combining nonlinear H-infinitely variable control of damping force and body roll on the Toyota Crown, 1999 plus Land Rover Discovery 2 ACE, 1999 Mercedes-Benz fully active hydraulic active body control suspension, first series production version on C215CL class, later in 1999 on W220S class and in 2001 on a 230SL class, 1999 plus Lexus LX470, 2000 Peugeot 607 AMVAR electronic damping control, 2001 Lancia Thesis with CDC Skyhook damping, 2001 Citroën NC5, 2001 plus Jaguar S-Type Cats, 2002 plus Mazda 6 Wagon 4WD, 2002 BMW 7 Series with active roll stabilization, ARS, plus electronic damper control continuous plus rear axle self-leveling air suspension, 2002 Maserati Cooper copyright, 2002 Cadillac Seville Streets, first Man Ride, 2002 Audi RS6 dynamic ride control, 2002 Audi A8 and Volkswagen Phaeton, adaptive air suspension with continuous damping control, Skyhook damping, 2003 Mercedes-Benz SL Class, active body control, 2003 Mercedes-Benz E-Class, Mercedes-Benz CLS Class, Airmatic. 2003 Chevrolet Corvette, some Cadillacs and other GM vehicles with Man Ride, 2004 Opel Astra IDS Plus, 2004 to 2007 Volvo S60 A4C active chassis, 2004 to 2007 Volvo V70 A4C active chassis, 2005 Citroën NC6, 2006 Ford Galaxy, CDC, 2006 Lincoln MKS Lincoln Drive Control with continuously controlled damping, 2007 Lexus GS, active stabilizer suspension system, 2007 Maserati Gran Turismo, 2007 Ford Mondeo, CDC, 2007 2009 Acura MDX, 2008 plus Audi TT Magnetic Ride, 2008 plus Alfa Romeo Mito, Green Clover Leaf, 2008 Opel Insignia Flex Ride, 2009 Hyundai Equus with electronically controlled air suspension and continuous damping control, 2010 to 2013 Acura MDX, 2010 Volkswagen Passat with adaptive chassis control, 2010 Volkswagen Touareg with adaptive body roll compensation, 2011 Opel Astra Flex Ride, 2012 Range Rover Evoque, Man Ride, 2013 Range Rover Sport, adaptive dynamics with Magnetorheological dampers and dynamic response with active anti-roll bars, 2014 Mercedes S Class. References. Nye, Doug. History of the Grand Prix Car, 1966-91. Heisleiten Publishing, 1992. ISBN 0-905138-94-5, 1986, Electronics developed for Lotus Active Suspension Technology, 1. External links, Bose Suspension,